this is SQL Friday with Ed Pollack. Is it SQL Friday 106? I think so. So for everyone who missed videos, I did a batch of videos. So if you go to the YouTube channel, just search for Transmocopter in the YouTube channel or SQL Friday or something. There's playlists for season 4 and season 5, which are now complete, and I started on season 6. So now I'm just 6 episodes behind, which is a lot better than a couple of weeks ago. There is a deadline of March 20, which I'm trying to meet to finish everything, which is it has all to do with the MVP renewal process, actually. Anyway, welcome back, Ed. This is your 4th time on SQL Friday.
Hi, glad to be here. It's your lunch, it's my breakfast. It's a great deal.
Yeah, and you're on SQL Bits, but virtually, and I'm not even on virtually. I'm just at home. So
it's a busy day, but that's okay.
Yeah, and is it today that you're gonna present on Bits?
Yes.
Cool.
Pile it all in, right? Pile it all in. It's a good time.
I once did 2 presentations on the same SQL Saturday, and it was so stressful to do the presentation. And usually I just want to sit in the sofa and relax, and I had just a lunch break between my first and second session, and I was like, now I have to prepare for that. And so I'm impressed that you're doing 2 presentations on the same day.
The difference with like 2 sessions at a SQL Saturday, versus 1 is just what do you drink afterwards, pretty much. You're gonna have a little like coffee and perk up, or you're gonna have, and some scotch or something. It's your choice. Beer.
It's what I like about Data Grilling, because there, when you're a speaker, you get a beer as you start your session, so you'll drink while you present. It's perfect. So.
That'd be nice, actually. That would be really nice, I have to say.
So it was a little bit weird. I did a morning session, I think. It was at least quite early in the day, so it felt a bit weird to have beer before lunch, but it's 5 o'clock somewhere, I guess. So,
it's often said.
Anyway,
very true.
We could talk about beer for an hour, or I could let you present. You're good. We talked about before I started the recording that injection is it's been on the top 10 and usually top 1 vulnerability in IT systems since OWASP started measuring, basically. So it's an important topic, and since I'm recording it, I'm going to throw it and shove it down the throat of all the developers I meet. So thanks for doing this. I'm looking forward to it. The stage is yours.
All right. Well, thank you very much for having me, Magnus. I really appreciate it. Your schedule is wonderful. I can get up at 6, 7 in the morning and hit it with a cool topic. So thank you. This is a timeless topic. This has been around for a long time. I've been speaking about this one almost longer than anything else because it never goes away. Somehow, despite all the awareness out there of security, all the breaches, all the times that I see my credit card information like stolen, I have to get a new credit card, and if 10 million of these things got released or whatever, this still happens. So this is really about awareness. I can't talk about every single aspect of SQL injection in 1 hour. There's simply too much. But we can really hit on all the important points that just keep us aware. It's really awareness key here. So I'm going to dive right on in. This is me. I've done lots and lots of stuff in the data community. I really enjoy this. Out of all this list right now, the most current projects are the Expert T-SQL indexing book. If you're looking for everything about indexing and more until the point your eyes bleed, check it out. And locally here, in case you happen to be over in the States, we're doing a SQL Saturday in New York City on May 6th. So if you're around, interested, feel free to hit me up. Otherwise, you can always find me on social media, email, whatever, and ask questions, chat, bug me. It's always cool. So this is going to be a quick intro and a lot of demos. Really a lot of demos into what can go wrong and how do we prevent it. It's really that straightforward. I don't want to make this big and complicated. I have way more bullets here than I need. But I have a lot of information in here. I will make all the slides and everything, the demos available afterwards. I'll throw them on GitHub and send a link over, and you can have them. So no need to write really fast or anything or screenshot 40 times. So really, what is SQL injection? At the simplest level, injection as an overall thing is just the ability to manipulate inputs in any way. It's not just SQL injection, by the way. You can muck with code. You can splice in things outside of SQL Server and have the same effect. So injection is really just in manipulating inputs. So they expect a first name and a last name, and I find some creative way to toss in some stuff that shouldn't be there. And as soon as the application's getting stuff it shouldn't get, you've been injected, and it's not good. SQL injection is simply that exact same definition, but with SQL code like T-SQL or in a different SQL language. And that's all it is. So basically, you can get stuff in there that was not meant to be there. That's injection. And it was, for years and years, as Magnus mentioned, the #1 security exploit, period. It's currently #3, which does not mean that we've solved it and it's getting better. That is not how this works. Typically, that OWASP list of security exploits and vulnerabilities is one that gets bigger and badder over time. Things don't pop off the bottom and go away. It's not how it works. So SQL injection is as bad as it ever was. It's happening more than ever. There's just other things that are also happening as much. There's a few new ones. You can read about them if you're interested, but we're not talking about those here. Those are other problems you can worry about on a different day. Basically, the moment a user can access anything they're not supposed to access, not only have they figured out you have SQL injection, but they're exploiting it. And that's all it is. The moment you can get to SQL Server and touch anything, data, components, modules, anything that you're not supposed to get to, that you weren't intended to get to, that's now a successful attack. It's an exploit, and you're in trouble. And it goes there pretty quickly, too, because anybody with even vague experience in hacking knows when they're getting successful at injection. They'll see errors, they'll see clues, they'll notice things that are kind of obvious, and they'll know where they're going. So what kind of things can people do when it comes to exploiting SQL injection? Even outside of SQL Server, one of the oldest, most classic ways is take a URL and muck with it. And we have more protections against that than we used to. But I still every so often run into a website where I can go up there and muck with the URL and get to pages I shouldn't be able to get to. That should never happen. There should be no way to take a URL and modify it and get to things you can't see. That's the simplest type of injection. I'm pretty sure I did it when I was in like middle school. You don't want to be vulnerable to that because once you're there, data can flow to the database legitimately, an illegitimate path, and you're in trouble. You could take dynamic SQL. Very often people just talk about dynamic SQL when it comes to SQL injection. It's not just dynamic SQL. It's part of it. It can be a big part of it depending on your environment, but it's part of it. If you have dynamic SQL and you have no parameterization, no input cleansing, it's very easy to muck with the text and insert things into there that shouldn't be there and do naughty things. You can fill out free-form text fields. A very common one is you put a % in to a text search, and suddenly you're getting back way more results than you're supposed to get. That's not really a good thing. And it's very rare that a text box is supposed to let you put in regex or wildcard characters or things like that. Another kind of exploit would be more of an internal one. Sometimes employees or resources or contractors to a company who have some privileged information will discover there's the ability to have SQL injection, and they'll use that to do a lot more than they should be able to do. A biggie is if people see error messages that are not app generated, they'll probe further. Social engineering is huge, of course. If there's a way for a person to give out information that can help people exploit, they will. Easter eggs, they're still out there. I don't know why developers do it in a way that could possibly be harmful, but there are Easter eggs out there that are harmful to apps, and they get caught, people get fired. But it's one way to exploit a system is finding something people put there intentionally. And why would you do that to your career? I don't know, but people do it, and I guess they think it's funny. And one additional exploit that kind of goes hand in hand with SQL injection is a performance bomb. Sometimes you have searches where you can search and get text results, and there's possibly maybe, I don't know, 1 billion rows in a table. I want 5 rows back. And so I search, I get 5 rows. But what happens if I put in wildcard characters and stuff like that, and then suddenly it returns the whole set of 10 billion or something? It may still filter it or do top 25, but if I somehow trick SQL Server into scanning a whole table, it could break things pretty fast. Why does this matter? Just sing along. Do you want a data breach? No, nobody wants that. Nobody wants that, and it's huge. Nobody wants a data breach. Nobody wants to be responsible for it. Nobody wants to be a part of it. Nobody wants to deal with it. This is all the stuff that frightens us to sleep at night, and we don't want this. So please, please just Why does any of this matter in this whole presentation? Imagine for a moment that you wake up one day and a whole bunch of data you're responsible for appears in the web. It's just out there. And your boss calls you in and says, hey, what happened? Why is this data out there? And you've got to figure it out. You're going to have a really rotten rest of your week or month or longer. So you don't want that. And you don't want your data getting out there anyway. It's just bad. So let's do a really quick demo of just some very basic SQL injection. This is super basic stuff. You may have seen it already. If not, cool. If so, great. So the most common kind of thing that happens in SQL injection, the simplest, the easiest, the dumbest way to get in trouble is something like this. You build some dynamic SQL. I throw in some search criteria, and I splice it all in and say, here's a select statement. Here's some search criteria. Just add it all up, concatenate the whole thing, and do it. And if I go ahead and I run the SQL, it does what I want it to do. It went out there to a table. It got all the people named Edward. Great. I wrote code that works. It compiled. Awesome. There's more to life than your code working, but this is a start. But if anybody finds that out somehow, sometimes through means like this is a common one. If you know anybody who has an apostrophe in their name, I guarantee at some point in their software development career, they're going to break some code somewhere. And hopefully it isn't like this. So same exact search as before, but we're searching for somebody with the last name of O'Brien, common last name, and ruh-roh, I got an error message, incorrect syntax near Brian. What did Brian do? If anybody sees this, they know it's SQL injection. It's almost the classic textbook scenario, unclosed quotation mark after a character string. Something bad has happened. And of course, if you look at your SQL, you can see what happened. There's an apostrophe here, and a single apostrophe breaks the string. You execute it, and you're busted up. Now, if you're lucky, the person who gets this will send your support an email saying, hey, I got an error message. Can you please fix that for me? Thanks. My name's O'Brien. If you're lucky. If you're not lucky, what's going to happen is the person will say, aha, I found something suspicious. Let me go probing and playing and finding things. And I'll try something like this. I'll search for Eric or 1 = 1. And again, this may seem like arcane weirdness, but to somebody who's done this before, this isn't hard to figure out. And you probably have all the time in the world to do this kind of stuff. Keep searching and searching, and eventually something happens. So I close my quotation here, and then put in some SQL. And then I reopen it and let it go back. I run this, and now I return every row in the table, which may not be what anybody intended. Maybe this is privileged data. I'm not supposed to see it all. I should only be able to see certain people or certain things, but now I've gotten it all. But now I know I can go further. I close the quotes. I started running SQL in my statement here. I put a where clause on, basically. So we can keep doing more and more and more. You can begin doing things like, hey, I want to find passwords. I want to get contents of tables. I want user lists. We'll see how what kind of permissions you gave your app user. Is it a sysadmin? Is it a DB owner? My mouth is watering just thinking about it, right? So let's hop back for a sec. There's a lot of causes of SQL injection. Some are easy to prevent. Some are hard to prevent, honestly. But there are many ways to prevent it. The most common causes very often are old code. Old code is the stuff somebody wrote when you were a company of 5 people or 3 people or 10 people. You were small, you were a startup, you were busy, you were moving fast, you did not have a database person. And I don't blame you. Companies that have 5 people don't have database professionals. You can't afford them, and they're not really, they're needed, but you don't really need them yet. So you don't hire them, you develop code, and over time you build up a code base of old legacy. I call it lazy here. It's not really lazy, but it's partly the result of just having not a lot of people. And so you build up a lot of code, and then it may not all be secure. A big one I see, especially in big companies, so we have the problems with small companies. In big companies, people get overconfident. You get a company with 5,000 people, you have a whole security team, they're really good at what they do, and you get overconfident because you say, hey, we have a security team, they're awesome, they're always testing and probing and poking and stuff, and they know best, right? Or you'll say, hey, our ORM filters all the data for us. It handles all that input stuff. It cleanses the inputs. You make assumptions, and those assumptions are almost always going to be wrong. We assume we haven't been hacked before, therefore we'll never get hacked again, right? That's a great thing to believe. We're never going to be hacked because we've never been hacked. Well, it's true until it's not. Unsupported, outdated apps. You think this is something we all know about patching our apps, but people don't always patch their apps. In fact, it's a huge problem Companies very often will avoid patching, avoid upgrading, avoid licensing fees, avoid downtime. And there's so many things to patch that it's easy to forget something too. You have obviously SQL Server, you have Windows, you may have your web server software, but there's also firmware, hardware, networking, any storage you have. If you're, on premises, you have more. If you're in the cloud, you may have a little less. But again, all this matters. And layering is key. I'm going to mention layering many times today because layering security is one of the biggest keys to solving SQL injection and similar exploits, because you're then able to make mistakes and recover from them. Whereas if you don't have any kind of layering in your security, your mistakes are fatal. This is really big. I put this here early on as just something to show what happens. Error messages happen. Nobody writes perfect code. Nobody. Things happen. I showed an error before where I had a syntax error by O'Brien or whatever. This is the same kind of idea. I click on through some forum, I get an error message like this, and what I immediately think is, hey, this is not an error message from the application. This is an error message coming out of SQL Server. That means SQL Server is exposing an error message to me, which means I have something in the SQL Server I shouldn't have. And so my immediate thought, if I'm being nefarious, is going to be, all right, what can I do to poke in here more and learn more and get more? And maybe I can take advantage of this because I have a direct window to SQL Server that I shouldn't have. And so the key with error messages is always, always, always make sure that your application presents a friendly error message. It doesn't be a cute little smiley or whatever with a panda, but just something that tells us there's an error, send it here, let us know. That's all. Here's your error code. Done. Never expose any actual app, any actual SQL or .NET or web errors or anything like that to users because they shouldn't see them. If you're lucky, they'll tell you about them. If you're unlucky, they'll hack you. That's simple. There's lots of sneaky exploits. So once you're in there, once you discover that SQL injection is a thing, that your name is O'Brien and you've hit the pot of gold, that's great. But what can you do now? And the answer is almost anything. And it really depends on your app permissions. If your app has more permissions than it should, which very often apps do, here's the kinds of stuff you can do. You can modify the T-SQL and get data you shouldn't be able to get. This can include sensitive data like passwords, addresses, phone numbers, credit cards, who knows what. And keep in mind that because I'm running SQL in SQL Server, some of your protections and security may no longer apply because I'm in SQL Server getting data. So the data may have been encrypted, it may have been masked, it may have been blah, 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 but because I'm in there with a privileged user, I may be able to get past all that stuff and do whatever I want. Could put new scripts in there. I can put a semicolon and then just put a brand new script in there to do something new. Like, hey, back up some databases and fill up their drives, or give me a whole bunch of data, or hey, let's drop some users. Why not, right? I'm in there. I'm going to test the boundaries of what I can do. I'm going to be evil. May as well be full on chaotic evil, right? And I can check and see what's there. If nothing, I can probe for information quietly and say, I want to know what objects are there. Select star from sys.objects, sys.tables, sys.users, sys.server principals, and so on and so forth. I could do select star from the sys.SQL modules and get the text to your stored procedures back. Kind of sneaky. I can steal your source code by getting in there, which is kind of cool. You can alter passwords. That can be evil. I can change permissions, change passwords. I can change the password on your account and see what kind of fun things happen later when somebody logs in again. Just cause trouble. I can then exploit it later and say, or hey guys, all your passwords are reset. You're screwed, right? And of course, you probably have backups, I hope. But if you don't, you'll be very nervous at that point. You should have backups, by the way. Please have backups. Have lots of backups going back weeks and months, please. If you're allowed, you can get outside of SQL Server. If you have volume management rights, if you have XP command shell or other things like that available, you might be able to get out of SQL Server and hit the command prompt and begin hitting the server with PowerShell or other scripting languages. So if the permissions are there, and on many servers they might be, you might be able to do things you really, really shouldn't be able to do outside of SQL Server into the Windows world or the network world. And once you're there, what else can you do? You can try to DDoS using all this and cause performance bombs and make decoys and distractions while you decide what you're going to do. People don't really do that as much as they used to anymore. More often than not, the goal of hacking is be quiet, be sneaky, be stealthy, and get what you need and then sneak out and hope nobody notices it. And I've heard of exploits in the wild recently, like hacks at companies where they were hacked in January and no one noticed until April. And that tells you that the hackers did a really good job, or maybe the security people, not really so sure. If there's bugs in app code, and bugs exist everywhere, weaknesses exist, it's just how it works. I like to believe that all the code I've written in my life is bug-free. I can't prove it. I wish I could, but I can't prove it. So if there are bugs available and you already know about them, or you find out about them, you could probably exploit them a lot better now that you have full access to a privileged user and the ability to do whatever you want. And of course, all the other evil stuff, you can drop things, take things, mangle stuff, encrypt it, ransom, blah, 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 blah. All the evil things that probably end in a Bitcoin wallet somewhere that you don't want to deal with. So if nothing else, please remember, and I'll mention this again later, have good backups. Make sure your backups work. Test backups, test recovery. There's entire sessions on backups out there. If you're not fully confident about it, find somebody in your organization who's confident about it, because you want that. That solves a lot of these problems, is having backups. All right, what are some other fun things we can do with SQL injection? Kind of like before, I'm going to have our search criteria and a search, and this is a little different. This is a classic search where I'm going to say, hey, I have a query, and this is not dynamic SQL. I have a query, I'm going to run it, I search my text box in the web for Thomas, and I get back all the Thomases, and life is good. That's cool. What happens if I, for whatever reason, decide to search for wildcard Tom wildcard, just for fun? Again, same query, no difference, no dynamic SQL here, really. It's just a search criteria being passed in. I do that, and I get some more results back. What if I search for percent at that point? I get back everything. So it's worth keeping in mind that SQL injection isn't just dynamic SQL. You can do it by mucking with strings and putting in things that may not be guarded against. I got back 20,000 rows here. Imagine if it was 10 million rows or a billion rows, the kind of fun that would happen on your computer, your database server, when I do so. Of course, I can muck with regex as well. If you love regex or hate it, whether you love it or hate it, you can do the same kind of stuff and get the same results back. Hey, just give me back all the things, right? Make up my search string. So these are all things that SQL Server allows, and therefore, if you allow it in your application, it's allowed, right? No one's stopping you, and if you don't stop people from doing something, I guarantee they will do it. That's how software works. If you allow people to do something, they'll do it, guaranteed eventually. You never thought somebody would search, in a text box for like, negative 9999999. Just let QA get at it. They'll make it happen. QA is your friend for this reason. All right, so here's another one here. Common behavior in an app, you have a login form of some sort, you have a password, the password gets checked with an ID and the hash and so on and so forth. This code happens in the back end. And let's say I go in here, I do a search for an ID of 3, and I get nothing back. Okay, there's no ID of 3. I try to log in as somebody who doesn't exist, or who knows what. This is what's supposed to happen. If I log in as somebody who doesn't exist, nothing should happen, right? All right, well, how about I muck with some dynamic SQL like this? All right, I don't have a username that's valid, but hey, let me union all and add some other stuff into here and goof around until I get what I want. Again, this is a valid way to SQL inject with SQL, dynamic SQL, is to add union all. It's not just the break the string, it's something like that as well. I do this and I get everything back. So what I really did here is I said, hey, union all, and then select whatever I want. Now I have to do the same table structure. So I have an idea what the table structure is. I can union all whatever I want into it and bring that data back as well. Comments can do the same exact thing. For example, I can put a comment here in the username, and then I can put some stuff in that's who cares, whatever, and see what happens. A where statement here says where the business entity ID is an ID, and the password hash is equal to a thing. I run this code, and I get something back. How did I get something back? Oh, I put in an ID of 3, which is valid. I got to that ID with the username somehow, but then I commented out the password part of the where clause. So I was able to skip the password check. Again, this is stuff that you think is obscure and shouldn't happen, but it's very possible. And once people know they can play with your code, they'll try all these things. They'll try all of them and more, and they'll know the extent to what they can do within minutes, no question. So comments can be used to skip SQL. So obvious thing here is put your code in different lines. Don't put it all in one line. That helps a little. Put the square brackets around things if you think security is an issue with things or if it's sensitive. But making everything one line means you can comment it out. Kind of a style thing. It's kind of funny. Yeah, you can do this. What else can we do? We can simply have the change to this. If I simply take that previous code and I just put the password hash in a new line, like I kind of just showed, still a problem. It still isn't totally fixed because now I just use this instead, right? I can use /* and get around it. So I thought that putting all my code in a new line would fix it. It helps a little, but the hacker then just said, okay, fine, you made me work a little more, I'll do this instead. So either kind of comment can be used to comment out code that then allows you to do more things maybe you shouldn't have been able to do. And again, this may seem arcane, but it's not. This is not hard to do, and people know how to do it. All right, let's jump on back. I don't know if you want to do questions at the end, Magnus, or in the middle. Totally up to you how you want to handle questions.
Whatever works for you. So regardless, if people have questions, please type them and we will figure it out, I guess.
Sounds great.
Yeah.
All right. One of the most common things we say about SQL injection and how to solve it is, let's just write some better code, right? We're writing bad code. Let's just write better code. We'll have better coding practices. We'll all go to school and go to training and be better at writing code. And it sounds great, but like, that's not really advice you can give people. Like, hey, just do your job better. Like, it doesn't work. It's too generic and it's too easy of a cop-out. And I've seen companies do this before. I've seen companies where simply some director somewhere said, all right, our code is just bad. We'll get everyone to some classes. They'll learn how to code better. They'll just be better. And the problem is that no one's perfect. We're all human. We don't write perfect code. We want to. We try to. But this isn't the perfect and complete answer. It never will be because nothing's perfect. You know, nobody has time and resources to review everything. So things get missed. Even in code review, things get missed. Stuff gets missed. It just happens. And we can't control everybody, especially as a company gets larger. Again, this is, you know, small companies have different problems from larger organizations. Larger organizations, what they'll often have the challenge with is you have a lot of developers all over the world, you know, all different places writing code, and it's very easy to miss things. So writing better code is good, but we can't control everybody's code in the full. It's just not possible. And we also can't just anticipate everything either. You know, some things are out of our control. Not all code is our code. Some code is vendor code or some other applications code we use or some platform software. I mean, you interact with SQL Server code, Windows code, tools you use, web server code. There's all kinds of code you interact with, and it's all different. And it could have bugs too. And we can't anticipate all of them, and we can't account for all of them. We just can't. It's too much. And things interact and evolve over time. This is just the nature of writing code, is that apps evolve. And, you know, the code you wrote 5-10 years ago may have been 100% perfect then, but then as other things changed over time, it became less perfect. And that's okay. That's life. So we're human. That's what it comes down to here. We can try to write better code, but it won't be perfect. And if we rely on perfection as our measure of success, we'll never succeed because we're not perfect. That's just life. So we can't rely on perfection. We can rely on onions, though. I like onions personally. I eat them like garlic. They make my breath stink, and I love them. In terms of security, though, think of security as an onion. Onions, like ochres, have layers, many, many layers. If you layer your security and you have many, many layers of security at the web tier, the app server tier, the database tier, and in each tier, you know, the network tier, and so on and so forth. If you have security in place in many ways, then you benefit from having an onion. The fact that if you have an exploit somewhere or a mistake somewhere or a bad code somewhere, it's possible that it won't kill you because above and below it, you have security. For example, let's say you forget to sanitize your inputs somewhere, maybe in SQL Server. You have a proc, it takes inputs, you didn't sanitize the inputs well, and it's possible that things can get in that shouldn't get in. But let's say your app sanitizes the inputs as well. You're safe now. You have a second layer, and that layer covered your butt, and you're good. So it's really important to think of security as an onion, not a wall. Security is not a wall. You can't build a wall and keep the enemies out. That was the way of looking at security 30 or 40 years ago. No one sees it that way now. Now it's like Swiss cheese. I think of the defense against Swiss cheese as an onion. These are all delicious things. I'm glad I already had breakfast. So what can we do about SQL injection? This is really the important stuff here. How do we defend against it? And this is just a long, long list. I'm going to try not to make it too boring, I promise. But there's simply so much to be said and so little time to say it. I'm going to try to say it all and do the best I can. The number one way to deal with SQL injection is to sanitize all inputs at every layer of your application. Wherever data is being passed from point A to point B, make sure somehow that input is just being checked somehow, that it's valid, that it's appropriate, that it isn't too long, too short, wrong data type, that people aren't hacking stuff in like percents and quotes or whatever. Just sanitize it, check it. This is important. And if you have weblogs, you can check them, and that might help you find things in retrospect. But beware of empty strings, percents, regex, nulls. Null's a thing. You can put null in. Null is fun. Symbols. If you don't allow certain symbols, don't allow them. Don't let people do things they aren't supposed to do. The next one's a biggie that I don't always see, and I wish I saw more. User-generated input is great. People love seeing free-form text because you can write anything you want. It's creative. It's interesting. It has upsides and downsides. Every year I see salary surveys for the data community go out, and there's always free-form fields for things like your position or whatever. And invariably, 20% of them will be things like Jedi Master or, space cadet or astronaut. And they're not obviously not real. Like, we're making these things up. Not everybody is the captain of the Enterprise, but you put that there for fun. So free-form text has two downsides. One is people may enter stuff that isn't useful. And two is there's more chances to exploit. If you allow people to type anything, they will type anything. So when you're building your app, consider what needs to be free-form text and what doesn't. If I'm asking for a person's role within the organization, could I just have a drop-down and maybe have an other at the bottom? The other will allow some free-form text, but most people don't click on other because it's more work, right? You'll just pick one of the ones that are there and move on with life. And if the choices are good, you're all set, right? So consider non-free-form text when possible. It's just helpful. It reduces the surface area for things to go wrong by reducing the number of places where a user can interact with your database somehow, directly, indirectly. Dynamic SQL is a great tool. It's amazing for maintenance and internal processes. It's great for ETL and moving data around. Beware using it for things that are user-facing. If a end user is hitting code that is dynamic SQL, you can use it, but you've really got to put in the extra defense there and make sure you parameterize it, sanitize it, and that there's no way that things can go wrong. In general, I just advise for web forms and things like that, avoid dynamic SQL unless you know what you're doing. If you know what you're doing and you can sanitize it in multiple ways and you guarantee it's clean and parameterized, good. But just have the extra beware, though, because there's a little bit of danger exposing people directly to dynamic SQL. Easy fix, make sure everything you have is updated. Check for security updates, CUs, new versions, and make sure that whatever software you're using, whether it's the biggie stuff like Windows and SQL Server, or other tools that you just happen to use along the way, Java, whatever, just make sure things are updated and are, have all the most recent security fixes, because unpatched software is one of the easiest vectors for exploits, because if there's a new exploit that comes out, it gets into the wild, everyone knows about it, and you're not patched, you're vulnerable to it, and everyone's trying to find the target of the brand new shiny thing. Like earlier, don't return system errors to the user ever. Make an app-generated friendly error, always. Doesn't matter what it says. It could be stupid. I don't really care. It could be a frowning iguana. I don't really care what it is. Have a error message go back to the end user that is meaningful and generated by you. Don't let anything else get out because nobody wants to see it. And parameterization is key. We'll demo that in a bit. Parameterize everything. It helps improve quality control, inputs, gives you more control. It's the way to do things. You'd rather parameterize than splice. It's just kind of always a better way to do things, and do that across the board in code as well. This applies to code. It applies to SQL. There's more. I have more. Always limit your result set. I have so much here. This goes on and on and on, and I have demos, and it's fun. Always limit your result set to what is needed, please. If you are in a web form, and you should always have a limit. It could be 25, 50. The user may be able to choose it from a drop-down, 10, 50, 100, give them the illusion of control, whatever. But don't allow people to return everything. If your table seems small right now, it may not be in the future. So ensure that your result sets are always limited to some number. Because if I can go in there and put some SQL inject something in that allows you to return more results, then I can break stuff. I can say, hey, give me 1 million, give me 1 million, give me 1 million, and suddenly your server is breaking, and I've single-handedly made your life miserable, and you don't want that. Data validation is really important. In the OLTP world, we very often rely on like, form validation and that kind of thing. But as you move more towards the analytics side, but really it's true in both. Always validate your data. Validate the data type, this length, the size. Does it fit? Is it correct? What's your date? Your date, month, day, year? Is it day, month, year? Is it year, month, day? What is it? Make sure everything's valid before you try to put it into a table, because you put data into a table that isn't valid, it will throw an error message, and that may or may not be a good thing. Or it simply may exploit your search parameters to see more than they should be able to see. Again, have the onion, have layers. I will mention the onion a lot in security. Any application has many layers, whether they're in the cloud, in Azure, in AWS, or they're on your own hardware somewhere. It has layers. Make sure every layer has security, and that each layer of security complements other levels of security. This makes your life easier. This means you can make mistakes, and they aren't fatal mistakes. And that may not sound like a very positive thing, but it is. It means you have basically HA for security. You have high availability, disaster recovery for your security itself. You can tolerate failures and keep going. And again, don't forget your backups. Don't forget your vendor software and your logging apps. You have a lot of other apps you might use out there to collect log data, to ETL data around, to create analytic data, to back things up. Make sure it all works. Make sure it's all updated. Make sure it's all secure. Please. If your app has super, super secure databases, but your backup drive's unsecured, that's embarrassing. And you don't really want that to happen. Now you've just all that effort for nothing. Your unencrypted backups get downloaded and people are restoring them. You're done. So I actually saw that happen in a company, not my company, but one that was competing with us years ago, where they had pretty good app security, but they had this like standalone server off the side that just happened to have access to a backup drive. And the backups just happened to not be encrypted, and they were accessible. And you know where that went pretty much, I think. And another biggie is make sure that app logins can't do more than they should be able to do. If you have an application and it has a login that is running under, then it should not be able to get to things it doesn't need. It doesn't need SSIS or a SQL Server agent. It shouldn't need touch backups or external programs or file shares. Maybe it does, and if it does, build security around it. But odds are very good it won't need access to the whole world. So make sure it only has access to the parts of SQL Server it needs and nothing else. Kind of the backup to all of this is have monitoring. Have web logs, have monitoring tools. Keep an eye out for what's coming and going on your servers. And you can build alerting in to let you know when things aren't the way they should be, or when you see things that are suspicious, or just have somebody review it every so often and take a look and just peek through the data to see what they find. This is not a bad way to dumpster dive. It's a great way to learn about your data, and you can automate a lot of it. But logging the stuff is huge. If people are trying to hack you, you can see that in your logs. If they succeed, you can see that in your logs. So just things to keep in mind. There's a whole separate area for privilege for users and their access to anything, really. And that is that ultimately a user should have or login should have no more access than it needs. It's that simple. Basically, if your purpose as a app login is to read data from some tables and then write data to certain tables, try to give it not much more than that than it needs. Don't give it other stuff. Don't let it be able to access backups. Don't make it SA. Don't make it DB owner or any of that. It's just not worth it. Ideally, an app login that the app is interfacing with people should have no more permissions than it needs. Granular permissions take more time, but it's still better. Even just having writer and reader is better than DDL admin and sysadmin or DB owner. So just consider giving it as little as possible. And also important is you have different modules in your application, different microservices, give each a different login. Again, this is work and people hate work, but it will save you a lot of trouble because it means if somebody actually accesses, somehow there's a security breach here or a problem here, anything here, nothing else gets affected. And that's important. So if you're ever exposed to anything, whether you're breached or not, you find an exploit, you find a problem, you at least know that that exposure is limited. So separate logins and get rid of SA. Take SA, give it an insane password, disable it, never use it. Nobody should be able to log in as SA. That's crazy. And you have a choice between Windows Auth and SQL Auth. In general, Windows or domain auth will be more secure. It requires Windows authentication. It requires domain control authentication. That is something that is harder to fake than a SQL Server auth login where you simply just need user and password. This is not always possible, but when you can, even if it takes a few extra hours of work, set up the domain login and use it because it will be more secure and harder to hack. So here's some more demos of stuff we can do, stuff we can see, what can we do. So in the world of T-SQL, we may need dynamic SQL, we may not, but when you see bad code, we can make it better. One of the easiest things to do is use SP execute SQL. So what I did earlier is I spliced in text, and it was the easiest thing in the world to hack, because all you got to do is just change the text, and you've suddenly been able to do things you shouldn't be able to do. One of the best ways to get out of this mess is parameterize. Parameterize everything. Parameterize your procs, parameterize your dynamic SQL, parameterize everything. Use SP execute SQL. So instead of splicing it all in, I'll execute my SQL command, which is just a select here. I'm keeping it simple on purpose. A parameter list, which is just one parameter, and a search criteria, which is the name Clark. I go ahead and I run this, and I get back all the people with the last name Clark. Awesome. It worked. I like it when my code works. What happens when the exact same code is used with O'Brien, like before? It works. I get back O'Brien, no problem, and nothing breaks. And this is a really easy solution, just parameterize. And I love SP execute SQL. It's convenient. It's easy to use. It's far simpler, and you have less breaking up of your strings. Honestly, like when your red blob of text is broken up by quotes and pluses and parameters, it's hard to read. This is actually more readable now. It looks like a regular query, but in red. Similarly, if I try to union all my way to success and get all the passwords out like this, I can do that. I can try to do that. And it won't work, because the user with the last name union all select, apostrophe union all select star from person.password, blah, 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 doesn't exist. That's a silly username. Who would do that? Who would name their kid Bobby Tables or whatever? You don't do that. And of course, you can cleanse inputs. Now, this is kind of a more dicey area. I highly recommend, if you want to cleanse inputs in SQL Server, you can do it the crazy way. You can do it the regex way. There's many ways to do it. If you need to do it, do it. But also do it in the app as well. Do not lean on this. And so, I've seen this before. This is ugly. I make a string, a silly string, and then I replace. You can do this. This is okay, I suppose. The downside is that you're going to miss some, because there's lots of other characters that I didn't include here. So if you know there's only certain characters that matter and no other ones, this is kind of valid, but it's messy. But if it's a long list, don't do this. Just don't do it. It's messy. It's scary. It will ultimately, you'll miss something, or it's just hard to maintain, because who wants to maintain that? Not me. Not me. So we can make a proc if you want to cleanse inputs before they get to the database. This is an example of one way to do it. There's many ways to do this. Feel free to do it in whatever way makes the most sense to you. There are both better and worse ways of doing this. This is a simple function I created. The function has a string that tells us what we're going to keep, which means everything else gets trashed. And then I go through and I just go in and cleanse it. Now, again, this is iteration, so this should not be stuffed inside of a giant query in a table. This should be, the person logs in, and here's their criteria. They're passing it as a scalar. You pop it through here. That's the right use of this sort of thing. So let's go ahead and create this function, and I can test it. This is a test. All the spaces and exclamation marks got removed. Okay, cool. That worked. All right, I'll try to pad it with percents and get back more than I should, right? Right? Nope. Nice try. So really simple regex there that just basically got back to the point where I'm only alphanumeric, and everything else gets omitted, which is important because that includes, the weird tab characters and end of line characters and stuff that, you might not put that in quotes really easily. Another random thing that can happen is I can say, hey, select star from blah. Now, this is crazy code, but I did see this in one place a long time ago in a production environment where they wanted the ability to run SQL queries against a production environment in secret, obviously in secret. No one does this publicly, right? But I saw this and it blew my mind, so I include it here. I can put in and pass in a table name, table schema, table name, and out pops data, right? Very easy to mess with if you discover it. In fact, it's too easy to mess with. I could put a semicolon and then, select star from person.password, and I can get whatever I want, right? This is just a complete exploit. I'm burying myself with this, right? Shouldn't do that. Of course, I can put brackets around it. That's better, right? Brackets are good. Brackets make it a little harder to exploit. And so I go in there and whoops, the brackets broke it, which is, I guess, better than getting star from person.password. But now I have a SQL error. We don't really want errors, right? Errors are bad, but this only really slows people down. So what else? They'll adapt, they'll get creative, and do things like this. So kind of the moral of the story here is keep the input cleansing simple, and don't do this, please. Don't do that. All right, let's create a proc here. Let's say we had to web search, we wanted to use dynamic SQL, and that was our choice of how to get data out of SQL Server at the end of the line. I can create a proc for it. The proc will go and it'll check for null. By the way, this is a good idea. If you allow null, check for null. This is huge. If you have a parameterized SQL, but your null is allowed and you let it get into your stuff, who knows what happens? ANSI nulls is not something that I want to deal with. So deal with null. And then I put a top 25 here on purpose. You can make it dynamic if you wanted or something else, and I get back what I want. So I can run this. I can do a search and get back what I want. I can do a search and get back nothing, which is also what I want here. So this is just stuff to consider. If you're building dynamic SQL, if you're building searches, notice there's no dynamic SQL in this proc, by the way. This is just SQL. But if you want to build code, just consider things like nulls and stripping out all the valid characters, alphanumeric in this case, and null, and a top, and so on. Your order, your like, all these things matters. Just consider each piece of this when you're running your code. And of course, I can do this and it'll return nothing, which is good. Nothing is good. I don't want to see the content of person.password, do you? Well, maybe. I don't know. Maybe you do. Let's hop back and do a little bit more before we take some questions or get interrupted by questions, whichever happens first. We have lots of tools available to us, and logs are a huge one. Use logs. Use your application logs, your web logs. Use your event logs. Any logs you have available to you, check them, track them. You don't have to check them by hand. You can create alerts and things that hit them that tell you what you need to know, but just check them. Pen tests are huge. Security tests are huge. Do not be afraid to have an outside organization come in, if you're not the experts, and smash your application. They're good at it. This is white hat stuff, and if there's bad things going on, they'll find it. Don't be afraid to do that. A lot of organizations are afraid because they're afraid of what they'll find. They don't want a company to come in, look at their data, find bad things, and tell them how insecure they are because they're insecure. But don't let your insecurities lead to app insecurities, please. I've wanted to use that one for years. Code review. Code review is huge, even in small organizations. Assume that anybody and everybody can make mistakes, whether they're a junior, a senior, or God, and check their code. Everyone makes mistakes. I make mistakes. Everyone makes mistakes. So code review is key. Most organizations have it. It's great. Just use it, and use it for SQL too. I know in some places the SQL scripts kind of get their own universe outside of app code, but make sure they're all subject to code review. Code review really helps. If you're making a silly mistake, it's a great way to catch it. Time is important too. One thing I didn't mention is that when it comes to security, hackers want easy, simple targets where the repercussions are low and the risk is low. If you have all your security in place, if your inputs are cleansed, if you have logging everywhere, if you have really friendly error messages, and you have lots of ways of handling these problems, you have layers and so on and so forth, it's going to take a hacker a long time to get anywhere, if they can get anywhere at all. And that time is huge because they'll give up. They don't want to deal with the possibility of getting caught. And if they see that you're relatively secure and you've taken made good decisions, taken good choices, they may simply say, you know what, the risk here is high because they know what they're doing. I'm going to move on. And why not? There's lots of other people out there to hack. They don't need to necessarily just hack you. So I do want to wrap up here to leave some time for questions because questions are important. This is a huge topic. I didn't cover everything. I can't try to cover everything here, but I can make us aware. Awareness is good. So this is a top vulnerability. It may be number 3, but it's number 1 in my heart, and it's going to probably always be a problem for all of us. Just consider the fact that SQL injection is huge, and no matter where it lands in some list, it's still happening, and it's happening a lot. One of the best ways to solve it is to have a layered security approach. The more layers, the better. This really is just about avoiding single points of failure. If you have 3 layers of security above your database, then they have to all fail for you getting hacked. So that's really important. You can guard against it, by cleansing your, sanitizing your inputs and having code review and having people checking logs and things like that. Because very often a hacker's not going to just jump in on the first try and get you. Things will happen, and you might be able to notice those things ahead of time. And just remember that good code isn't enough. I know I mentioned it in a whole big slide that says, we'll just write better code. I wish it was that simple. It's not. We all fall back on that because it makes us feel good. We all write great code, right? I'm awesome, but it's not good enough because things go wrong. And really last thing to say is don't be that number. Don't be that company. Don't be that person who ends up in the news, because it eventually ends up somewhere in the news that someone got hacked. And if it's SQL injection, they'll know it. So don't be that stat. It's not worth it. It's not worth the time, the effort. It's not worth your career, because these are things we can guard against. So don't be a number. I'm going to take a break there and say thank you and put all my info up and leave us a few minutes to chat, have questions. Maybe our eyes are glazed over. Maybe we're all running around house on fire now after hearing all this.
We have a question from, thank you, first of all. And Power DBA class has the question, are there any known scripts to search for anti-patterns? It's a big topic.
That is a good question. I actually do not know off the top of my head of a set of scripts that are built to search for anti-patterns, but I can answer that question afterwards. I'm going to grab me a good old notepad over here, move it away from here, and make a note. And here's what I will do, because I like having fun. I will see if anything is out there, and if anything is not out there, I'll write it. That sounds like fun, and that'll be a great follow-on to the session, too. We have an article about how to find anti-patterns, so I would love to.
I'm going to put a link in the chat because Malam Mahadevan did a presentation about using script DOM to find anti-patterns. It's not super easy to use script DOM, but it's a way to I don't know if you ever tried to search in SQL code using regex for specific patterns, it's hard. But with the script DOM, it'll tell you this part of the code is a comment. Don't bother about it. This is a parameter and stuff like that. So it makes it possible to do those kind of searches. So I can't type and talk at the same time.
It's hard. No, that's great. That's great. Like I'd be interested in seeing if those anti-patterns include, the security concerns we have. They probably do. That would be cool to take a look at.
I think it was more about, finding ridiculous data types and stuff like that. So kind of on nowadays, most of the code we deploy, we don't really go into the server and deploy it ourselves. We have some kind of automated build and deploy process, and then in the build pipeline you can run the checks with script DOM, or I encourage people to use SonarQube or Fortify or whatever you have and can afford, and just do automatic screening of the code as you check it in. So because it's helpful, even as you say, even we make mistakes, even though we worked with SQL for 20 something years, and we're going to make mistakes, and we don't want the users to have their data exploited because I made a mistake. That wouldn't be good for my insurance, and it wouldn't be good for my conscience either. So.
Yeah, onions are good. We love onions around here, right?
Yeah. Have a lot to think about now. Thanks, says Kent. Yes, me too. Database Health Monitor lists some things as technical debt, but that's not open source, says Power DBA Class. That's fair. I think one of the biggest things, it has nothing to do with injection, or maybe some. If you do a search and then you have a drop down, do you want to see 25, 50, or 100 results, and you change it to 50, and you see on the query string that you get a 50 in a parameter, and you change it to a million, then you're not able to, from the application as such, choose anything but 25, 50, and 100. But in the back end, it's not checking that number. It's just doing whatever you send to it.
Yep, I am
The layer,
100%
yeah.
in favor of. I love validating inputs and limiting user input when possible, only because if you let people do anything, they'll do anything, and that anything could be scary, and it always is.